Good afternoon, everyone. Welcome to the Canadian Electricity Association's Conversation webinar series. I'm Dave McKendry, Senior Fellow at the CEA, and I'm pleased to be your host for today's session. The CEA has worked with our corporate partners to develop this conversation series, which focuses on solutions to current and future challenges faced by our industry. Today, Aggreko Canada will be presenting Expediting Capital Projects while improving reliability and customer satisfaction. Major utilities are spending more than ever on their transmission and distribution systems, largely driven by capital expenditures to replace aging infrastructure. Capital investments, projects in today's power industry must address regulatory uncertainty and increasing customer expectations. By turning capital projects into a functional strength, utilities can benefit from more reliable assets, greater customer satisfaction, and higher shareholder returns. This webinar explores the benefits of enabling transmission and distribution companies to leverage new ways of expediting capital investment projects related to reliability and replacement of aging infrastructure, while improving reliability metrics, customer satisfaction, and potentially reducing OM&A costs in the future. Our presenters include Wajid Ali, Utility Sector Transmission and Distribution Specialist, Eastern Canada, Dave Bell, Utility Sector Manager, and Aaron Cook, Engineering Manager, of course, all from Aggreko. Before we get started, please feel free to type questions into the question area on your webinar screen, and we'll be asking those questions towards the end of the webinar. We'll be sending out a copy of this presentation along with the webinar materials after with a post-webinar survey. We would certainly appreciate your feedback. We're also interested in any topics that you would like to see as a part of this conversation series. With that, Waj will now turn the webinar over to you.
Thank you, David. Thanks for the introduction. Hello, everyone, and welcome to this webinar. So as Dave said, the title is Expediting Capital Projects while improving reliability and customer satisfaction. My name is Wajid Ali. I am the Account Manager, Transmission and Distribution for Eastern Canada with Aggreko. With me on the panel is David Bell, Sector Manager, Transmission and Distribution, North America, and also joining us is Aaron Cook, Engineering Manager for our North American team. Aggreko is basically enabling transmission and distribution companies to improve grid resiliency, reliability, and capital productivity. We are working as a partner with various T&D companies during emergency plan work and increased demand scenarios, utilizing our engineering design services, integrated solutions that includes our generators, transformers, switchgear, protection control devices. Along with that, we have hands-on experience that we have completed various projects with numerous T&D companies in North America in the region. The purpose of this presentation and the purpose of this webinar is today we are talking about the planned projects and what are the trends that are driving those planned projects, what we have seen in the industry so far, and based on our work experience with the leading T&D customers across North America, the major driver for the planned projects, that's OM&A and capital projects, is basically due to the aged infrastructure. As we all know that the infrastructure in North America was mostly installed through the 20th century in earlier or mid 20th century, and it needs to be upgraded or replaced so that we can serve the future years to come. Along with that, there are a lot of initiatives towards the grid hardening and modernization initiatives, which is, of course, another part of the planned projects. And that is because we have to replace so many devices that are either obsolete or they have filled their lives, such as protection devices, insulators, CDs, VDs, switch gears, and so on and so forth. And then the third thing that we have seen, which is driving the projects in the industry, is the reliance on the power. So as we all know that the power requirement or the demand in power has gone down in the recent years. Having said that, the reliance on the power has gone up, which means that if we don't have power for a minute or for a couple of minutes, it's hard to think about living without power. So power or electricity is kind of part of our life. And if there's no demand, if there's no supply to the power, then we are also having a lot of significant impact on our lives. Having said that, we have significant demand on the clean energy and the clean energy initiatives, and that drives, part of it is the electrification initiatives that's globally been applied, and Canada is part of it, and we have to meet our emission targets to meet the clean energy requirements. So these are the three major trends that we have seen driving the project. That leads us to our next slide of the presentation. How do the industry typically run conventionally these planned projects? The planned projects could be either for maintenance purposes or could potentially be for the capital spend. What we know as a status quo, that historically these projects are either the most preferred way is to have a load switching. As we know that most of our grid, majority of our grid is interconnected, and there's always a potential that we can do load switching while we are doing the transmission or distribution project. That's the most cost-effective way, and that's the most preferred way. But along with having said that, there are some challenges in adopting that option. And the challenges are that if we do the load switching, there's a potential that the alternative source where the load has been switched could either become overloaded or may not have the capability to cope with the load that has been transferred. And having said that, it is not always the feasible solution, just because of some of the feeders may be radial feeders and may not have that option available. So if we don't have that option available, what do we do? The other option or alternative could be shoe fly, but shoe fly is also cost effective in the event if it is for longer outages. But what if the outages are shorter? How do we do that? Shoe fly is not a cost-effective solution in that scenario. And having said that, it's not always practical, as we all know that our terrain and our topography in some of the territories is not easy to even install the shoe fly or do the shoe fly method. And having said that, it's not always the safest option either. The third option that we're looking would be to do the work hot. So working hot is sometimes a cost-effective solution, but most of the time it is not, because we need to have a much skilled staff or much skilled technical staff to perform the work hot. It's not always the safest solution, and most of the utilities in the T&D industry would avoid using that option if there's a possibility. So the last option which we are looking at is taking an outage. Taking an outage is, for sure, it's kind of an option where you can work safely, and that's what historically been done in the industry, but it's sometimes it's not feasible. And it's not feasible because either the scope is too large, we need to take an outage which may last longer than 6 to 8 hours. And if it is longer than 6 to 8 hours, then as per typical industry practice, that's not a feasible outage. So what do we do in that case? In that case, the possibility is that we may defer the project, or we may take multiple short duration outages, which is not an efficient way and may not be very capital productive. Along with that, if we take an outage, just imagine that how would it impact your SAIDI and safety numbers, and that's what most of our decisions are made of. Whether we take an outage or not is totally dependent on how and what kind of impact it has on SAIDI and safety. Along with that, what kind of customer impact it's making. If there's a larger industry, we may impact our industrial customer. So there are a lot of challenges, and there's a fine balance to talk about taking outages. Having said that, it leads us to our next business challenge. And the business challenge is, how do we create that fine balance between the grid resiliency and the immediate reliability? So talking about that, as we know that if just before that we talk about the grid resiliency and reliability, we know that there's a common trend in the industry that the T&D companies, T&D utility companies in the industry, they're always striving for the grid resiliency. And by definition, what we understand the grid resiliency is the performance of the grid in the longer over a longer term of years, which means that how my grid is performing and how reliable it is over a longer period. However, there's a grid reliability factor as well. And our understanding is the grid reliability is the immediate impact to the SAIDI and SAIFI and KD numbers, and it's basically measured on annual basis. So whenever we sit together and we talk about the planned projects, we do talk about and we do consider these factors when making the decision whether to take an outage or whether to defer an outage. So if we take an outage, it definitely impacts my immediate grid reliability, but on the other side, it improves my grid resiliency. And again, there's a fine balance between the two. The alternative option is we don't take an outage. In that case, my grid reliability would improve, but my grid resiliency over the longer term is going down. And there's a risk that my capital for that year may not be spent just because the outage has now deferred to next year. It takes us to our next slide, which talks about the benefits. So the option that we talked about in the previous slide, which was deferring an outage. What happens if a T&D industry, in our understanding and talking to the major utilities and working together with them, our understanding is if a project is deferred, if an outage is deferred, what are the consequences that we may see over a period of year or maybe over a longer duration of time? The first thing is the capital that was supposed to spend and that was supposed to be invested in the business has been deferred. Along with that, the long-term resiliency is affected. So the grid may not be as resilient as we would have anticipated. At the same time, the ISDs and ISAs that was scheduled to be completed in that year has now been affected. At the same time, while the grid resiliency is affected, the trouble cost has gone up, and it could affect the grid reliability in the longer term. So the second option would be we go to the alternative, and that is we take an outage. But taking an outage has significant, if it is a outage which has more customers or it is longer duration outage, it could have significant SAIDI impact and SAIFI impact as well. At the same time, if we are taking multiple outages to complete a longer term of the project, there could be capital productivity issues as well. But don't forget about the customer dissatisfaction factor, which mostly is a play, as we know that we don't want to be, no industry and no T&D company would like to be in news article. There's also political and public pressure not to take an outage, and multiple outages means multiple safety touches. So why do we talk about planned work? And why we understand that planned work is important to talk here and to discuss here on this slide. So when a utility comes to us and we talk about the reliability improvement, typically we start with the emergency response and how we can help. And definitely we have a plan and we can help, and that's what we do with our partners. We work together with them in emergency response and how we can plan for that. But here we talk about the benefits of the planned work. So what we have seen, we worked with one of our major customers and we got a data from them for the past 3 years. And interestingly, what we have seen is that the planned outages were 12%. So the CMI that were caused by the planned outages were almost 12% of their annual CMI caused. So it makes sense to target the emergency. It makes sense to target the emergency work, because if you look at the bar here, the blue line, the blue is representing the unplanned work and the green is representing the planned work. So like logically thinking, you would say we go for target the blue work. But the problem with the blue work is this is an emergency work. So we never know where emergency could happen. We never know what could fail. We can't predict it. But the advantages to the planned work is that it's predictable and it's manageable. And along with that, it expedites resiliency and it gives us capital productivity. When we say it's predictable, because we know about when this project will gonna happen, we know how it is planned, we can sit together, the utility industry, they know when this work will gonna happen, so there's a plan for it. It's not like an emergency work where you cannot have resources sitting for responding to the emergency. It's a planned work. You have the prediction for it. It's manageable. You have the resources. You can plan for it and you can manage it in advance. So if we target the planned work, the advantages are that the CMI that is caused by the planned work, how can we mitigate that? So we talk about if we could mitigate the CMI, if we could totally eliminate theoretically the CMI caused by the planned work, it's quite possible that we can hit the SAIDI targets for the year. So looking at the bar, if we are able to mitigate the CMI caused by the planned work, what does that mean? Does that mean that we do not do the planned work? No, it's not. It means that if there's a way that you can still do the planned projects, but you are enabled not to impact the customers, which means you do the work, but you don't impact the customers. So that's what we talk about in these slides. We took the data for the past year from one of our major utility customer, and we look at the data for the outages, for the planned outages, they were longer than 6 hours or more. And what we realized is that there were 55 outages taken for the planned work. And those 55 outages were causing a significant amount of CMI. And that CMI percentage was 80% of their delta CMI. When we say delta CMI, so as we all know that in the industry, there's a target for the SAIDI and all the utilities strive to hit the SAIDI targets, either to improve it or to hit the SAIDI targets. Now, when we say delta, delta is the difference between the given targets and the actual SAIDI numbers. So that utility, when we analyze their data, they had 55 planned projects, and those 55 planned projects, the CMI caused by those projects were 80% of the delta CMI, which means if they would have by some means eliminated the CMI which were caused by the planned projects, they would have actually hit their SAIDI targets for the year, because they were trending by 10% typically over the past 3 years. They're trending 10% above their SAIDI targets. So if for some reasons, if they're able to mitigate the CMI which is caused by the planned projects, they would be able to hit their SAIDI targets. So that makes sense. Having said that, it makes sense that we target the planned projects. And focus on the planned projects and mitigate the CMI which is caused by the planned projects. Here we talk about, we can give you an example of a utility in the Western Canada, and that's a real project that we completed in the last year. They had a challenge, they had a real challenge. They were going to reconductor a project. They were going to reconductor a feeder and complete the project at a 25 kV system. The problem and the challenge they were facing was how they can reduce the impact to the customers, and how can they, while doing so, how can they complete the projects. So if they are going to typically perform the work, they either have to take multiple outages to perform that work, or a period of 4 to 6 months, multiple shorter duration outages, 4 to 6 hours, bring the crew, work for 4 to 6 hours, then mobilize, demobilize, go back. Then after a month, they come back, do another outage, do the portion of work, mobilize, demobilize, then go back. And every month they take an outage for say 4 to 6 hours, and so on and so forth. For the next 6 months, they do the project. But the problem with that option was they were not able to complete the project in a given period of time, which is within the given year. They were using that option, they would not be able to hit their ISDs and ISA for that year. What they thought, they could opt for another option, which is doing the work hot. But working hot has its own challenges. First thing is they needed to have a very specialized human resources, specialized technical labor to do the work hard. Along with that, the cost for working hard was actually adding up, because they have to hire special special human resources. Along with that, they have to hire special contractors to do the work hard for them. So together, through discussions with the utilities, we both realized that what they could do is they could de-energize the system while they can keep the customers energized. Now, this sounds like how you're gonna do that, how you can keep the customer energized and at the same time you de-energize the line. So they got this realization that they can do this work, they can opt for this option, and by opting for this option, they de-energize the line, that portion of the sub-transmission line, to complete the work safely. And at the same time, there were no recorded safety and safety events on their metrics. And the benefits that the customer achieved were significant. The first and the foremost were, as they were looking to lower the impact to the customer, so while keeping the customer energized, they basically achieved their goal of keeping the customer satisfied. So the customer were extremely satisfied with the performance of that utility. They reduced the safety touches by almost 66% by doing the work on a dead circuit, and by doing it just with a one switch over. Along with that, they were able to meet their CapEx targets for the year, and they even realized the capital in the shorter duration. So initially, if you remember, they were going to do the work within a duration of 4 to 6 months. While having this capability, they were able to do the works in less than 3 weeks. So they shortened the project duration, and they expedited their capital spend. And they completed the project within the same year, which was their main goal to achieve. At the same time, there was no immediate reliability impact to the grid. So there were no safety and SAIDI recorded events. While completing the project, what has happened is they expedited the grid resiliency. So the long-term grid resiliency, if they were going to do the project typical way, they would have completed it in 6 months. Now, since they completed it in shorter time, within 3 weeks, they saved all that 5 months of grid resiliency issues. And overall, project cost was improved. So there were exceptional benefits to that project, and that's why we thought we have to bring it up to our audiences here so that they can understand the additional measurable benefits while doing the projects. While that project which we just discussed was for distribution utility, here is another project for the transmission system. We had a customer in the northeastern seaboard. They had a situation, the challenge was that they had a project, they have to replace, like an OMNA project, they have to replace osprey nets. But the problem was that due to the windstorms they had early in the year, they were not able to take an outage. And due to the voltage on the system, they were not able to do the work hard. So they were kind of in a limbo. They cannot take an outage because they were trending very low on the safety numbers. And at the same time, they had to complete the project. So the executives and the operation team, they kind of having that challenge and that goal to complete the OMNA, because that was towards the reliability targets of the year. However, the challenge was how they can do the work. So somehow they needed to have a mean which can keep the customer energized. However, at the same time, the circuit could remain de-energized and they can do the work safely. So when they realized that there's an option which could help them keeping the customers or the end user downstream energized, which you can see on this hand drafted drawing here. So they were able to keep the customer downstream energized, and they took the circuit of 115 kV circuit between that portion. They took it off. They actually transferred to the lower distribution level, and the 115 kV was de-energized. They were able to complete the project. They were able to at the same time, they had a lot of benefits achieved through that project. So when they realized that they can do the work dead and they don't need to do the work hard, and at the same time the customers could be de-energized, they were able to meet all their targets for that specific territory. In the end, they were able to meet all the benefits, and the benefits were huge. First thing is they were able to complete their OMNA project, which was just a replacement of the removal of the osprey nets and just some other minor repairs at the same time while keeping the customer energized. However, the additional benefits that they achieved were, number one, the customer satisfaction. So again, as we said, customer satisfaction is always one of the prime factor while deciding on the outages, on the plant outages. So in this case, the customers were satisfied. They didn't have a single SAIDI or SAFE events because they were able to switch within less than 22 seconds. And there were no safety concerns because they had to work on the circuit that's now being de-energized. At the same time, they were able to bundle the OMNA and CAPEX. So they were this option actually enabled them to complete the OMNA and bring in the CAPEX work together. And while the circuit is dead, they were able to expedite the CAPEX, which was planned for the next 3 years on that circuit. But now, since they realized that the circuit is dead and they have this additional capability that they can expedite the CAPEX and bring the CAPEX works instead of having it completed in 3 years, they could complete in less than 55 hours. Additional benefits were, as I said, the customer was satisfied and they have reduced safety touches. At the same time, they bundled the OMNA and capital work, and there were no reliability impacts. They were able to save 28 million of customer minutes of interruption, which means there were no SAIDI events, and the customers were served 28 million minutes of power without interruptions. They expedited the grid resiliency because they're one of the that circuit used to be one of the worst performing feeders. So after completing the project in the last 18 months, they haven't seen a single interruption on that circuit. So the grid resiliency has expedited, and that circuit is now one of their best performing feeder. And at the same time, they have capital productivity since they were able to expedite the capital and do it in a single installation instead of having a multiple mobs and demobs. And at the end of the project, when we sat together with the project team and we sat together with the director of grid operations just to have a post-project review, we got this this compliment which we are sharing here. And what they said was that they wouldn't have done the project if there were no way to keep the customer energized. So if there were no way to keep the customer energized, they wouldn't have done that project. The benefits to utility were enormous, and they are looking to utilize this concept in coming many projects. Now, having said that and talked about a number of couple of stories, we went through a number of data. We went through some data with one of our major utility customer, and we evaluated and analyzed their data for the previous year. And we took a sample of a substation where they had taken 3 outages throughout the year just to perform the planned projects. So what has happened is that they have taken an outage at the same substation for 3 times throughout the year, and the reason was that the work that was to be completed, they were not able to complete that work within a given duration of 6 hours or 6 to 8 hours time frame. So they have to come every 4 months or every quarter so that they can complete the work. And for that reason, they have to take an outage 3 times for 6 to 8 hours throughout the year. The reliability impact that it has caused was 3.3 million of CMI. And at the same time, since they were not able to complete the project in a single outage, so the long-term grid resiliency impact was also measured based on the data, and overall safety touches and customer interruptions were recorded. What we did in a hypothesis, we sit together and we analyzed that if they would have done that project by keeping their customer energized, they would have achieved additional benefits, which you can see here, which is encircled in the red mark. They would have reduced the number of outages, but at the same time, they would have achieved the reliability impact, right? So they would have achieved the reliability goals, and they would have actually mitigated 3.7 million of CMI cost in that year. At the same time, they would have achieved and reduced the safety touches. So the work would have done more safer for them and would have done they wouldn't have any single recorded interruptions to the customer. So at the same time, they wouldn't have any safety events. Now, the interesting question which the customer would ask us, how do we do it? And what is the concept that we're talking about here? How do we keep the customer energized? So how we do it? We sit together with our customers. We ask for them some data where we get the load profiles from them. We get the protection requirements and the site limitations. And then we agree with them on what we can do and what are the desired goals and measurable results, like what the customer is trying to achieve when they're doing a planned projects, and how we can impact and what is the value that we can bring to the table. So we sit together, we work as a partnership with our customers, and it's kind of a bi-directional consultation process. So we share our analysis, what we have done on their system with them, and we ask for some feedback from them. We get together and with our design and engineering team, which involves our safety team as well, we sit together and we make out a plan on how we're gonna execute it. We put together a package. Once we realize what the problem is, we put together a package. We present it to our customer in a way that we sit together in a room and we go through the whole scenario on how we're gonna execute it, what would be the measurable benefits, what we are measuring here, and what would be the outcome, and what are the challenges. So we sort all those things out. We sit and we go through the whole steps that's shown here, and finally we make a plan together and we go from there. Now you would imagine, assume, or you would imagine, how would it look like? How do we do these projects? This leads us to the next slide. So on here, we typically, this station or this drawing, which you can show on the screen, is typically how do we do it? We sit together, we finalize what kind of voltage level we're talking about, what would be the transformer, what is the transformation level we're talking about, what are the protection devices needed for that system. There's a lot of background discussion that goes between our engineering and the utility T&D engineers. There's a lot of discussion that goes on with their operation teams. There's a lot of discussion that goes on together with their stations teams. And then we figure out what would be the appropriate and the most suitable protection devices, what would be the most suitable switchgear devices or the breaker devices or the switching devices. We get the data from our customers, we analyze it, and we propose our solution that comes into play at the final stages of the project. And then we develop a single line diagram, we share that with our customer, we get it approved with them, we do some sort of consultation with them, we understand their challenges, and we share our challenges with them. And we get together and we work as a team together to get the work done. So on the screen, you can see some screenshots and snapshots of our typical single line diagram and our floor plan for a typical transmission project. And then we look into some more closer pictures of how it looks like when it is on the ground. We have a very skilled staff and that comes to the ground with the gear, and they have hands-on experiences working with various T&D utilities in the region. We have dedicated gear, and we have dedicated protection control devices, and so on and so forth. So that leads us to the questions. If you have any questions and answers, please feel free to ask. Thank you, everybody. Back to you, Dave.
Well, thank you very much, Waj. Wow, that's another fascinating study that you've spoken about. Good to have you on camera, and certainly would welcome your colleagues, Dave and Aaron, to join us as well. One thing I'd just like to. It's fascinating what Aggreko is able to do to effectively jump in on the knight on the white horse and help save the day. And when I hear what you do, it sounds to me very much like a series of doctors who've got a challenge with a patient with a bad heart. And it's hard to work on a faulty but yet still beating heart. Whereas if you can just reroute around the heart, allowing you to do the work on the damaged heart, it's a lot quicker, a lot safer, a lot better results, and then you can get back to your regular business. You step in, take on that offboarding solution, and then allow the work to continue. It's really, really remarkable. And I believe you've got some news, some work that Aggreko has been doing in Ontario. Could you tell us a little bit about what you're doing? It's live. It's happening right now as we speak. Tell us what's going on.
That's right. Thanks, David. Thanks for the feedback. So what is happening is we are running a major project, which currently I'm at the site right now while I speak. And with me is David Bell. We both are at site right now. And the project is, we are providing almost 30 megawatts of power. And we are kind of actually practically giving power to two major towns here. I will leave it to Dave to share some more details about it. But if you want to check news on that one, we have shared that link in the local newspaper, which is in the chat box with the audiences. So if anybody's interested to know more about the project, it's actually in the chat box.
Oh, great. Thanks, Roger. David, tell us a little bit. Petawawa area, I believe.
You're right. Just down the road from you guys. Yeah, just down the road, just back from my old stomping grounds. But yeah, it's really what was happening is they have a 115 kV circuit. It's done its work, and so now it's time to get that changed out. And the challenge is that they came into a lot of these dead end changes within the system. So when they looked at their total work plan and their critical path on reconductoring the project, what they had to realize is that they would have had a major impact on the community. And so the utility didn't want to have that major impact. The other thing that would have happened is that, to Wadge's point earlier, is it would have taken a long time to get this done in short bursts. And so what they wanted to do is ensure that that resiliency to this area is met in a quicker fashion. And so, and then the other problem that they had as well is they had the challenges of managing the reliability metrics year over year. And so what they did is we sat down with them, we discussed a couple different options of how we could do that. So at one point, what we said is, well, we'll set up our equipment at two separate substations. And at one point, we were just going to come on live when they needed to do the dead end work. And they thought it was better, and they could actually see productivity in their capital employed, meaning the amount of work that they could get done faster to do that work. And David, as you know this, the utility is just overwhelmed with the amount of work that they have to do right now. So anytime they can make improvements, it's not just about money, it's also about making sure that they have the right resources at the right time to do the work. And if they can expedite their capital productivity, they were looking at that as well, or improve their capital productivity over that period of time.
Great.
And so and so when we look at this project, it's going to be completed now in 3 weeks versus 3 to 4 years.
Wow.
It's going to be, it's one and done. Once it's done, what's interesting about these projects is the utility knows what to do. They know their system so very well, don't they? And they know what needs to be improved. The challenge is balancing that customer satisfaction and that reliability metric in the interim. And how do I deal with that the most effective way? And we just gave them a tool so they could do their thing.
That's really cool. What are the towns you were mentioning? There's Petawawa and a couple others.
So it's Petawawa, Pembroke area. So there's other towns that are in the area, Forest Lee, in that area.
Wow, you know, I come back to it. It's like that utility in a box solution that you guys provide. Hey, just a reminder to all of our listeners: if you've got a question on any of this marvelous technology, please just tap it into the webinar screen, and we'll get to it. We do have some questions that have come in so far, guys, and I guess one of the questions is, so with this solution, which I understand is both available for transmission or distribution companies, what specific job functions within the utility do you think would be most interested in this topic or in the solution that you provide?
Initially, what we were seeing was the asset planning and asset management group. As you know, they're always juggling all these different balls in the air and just trying to see what the system is going to do and how the system will react at any given time. And they were looking for other ways and tools to do that. What we found throughout the organization as well is we noticed the differences we were making in capital productivity and safety. So the safety, safety belongs to everybody within a utility. and they have all these different metrics, right? So you have your safety on one side, you have your capital productivity on one side, you have the people that care about your reliability metrics on the other. And sometimes what it was almost like competing metrics within the organization. And anybody that works for a major organization knows that those always exist. But what we could do by just taking care of the customer, from the utilities perspective, they found that those competing metrics kind of go away. And what they do is they actually align with all the same metrics that they have, and it's a goal as one. And so when you notice that, the executives have seemed to take a real liking to this as well, because now they can win. Together.
Great, thank you. And I know, Aaron, you're very much involved in the technology side of making this equipment magically happen. So when you're working with your transmission and distribution customers, what do you need from the customer so that you can do the work that you do?
Well, we need to know at which point they're proposing to do the interconnecting. We need to understand and be very heavily involved with the design of their switching scheme. So we need to know which circuit breakers, which switches, etc. they're planning to switch off to isolate the parts of the circuits or the distribution network that they plan on, working on, performing maintenance and upgrading. We need to know voltage, obviously, voltage phase to phase, phase to ground, unbalanced loads, power factor, direction of reactive power flow. We need to know peak loads versus average loads so we can estimate fuel consumption, and we need to be able to obviously provide that maximum amount of power that's needed during peak time. So those are just some of the things that we look for.
Yeah, that makes sense. Thank you very much for that. Next one that's come in is, so how has COVID changed the need to improve capital productivity and or capital employment? I don't know, David, do you want to take a crack at that one?
Yeah, it's a big deal. So obviously, as we dealt with it, it's a black swan event, right? We're learning through this. Everybody's learning at the same time. And what we found was the initial trend was, how do we keep continuity of service to our customers during this period of time? And how do we ensure that they feel comfortable and that the utility is going to be available to them? So that we've done a lot of projects that have helped support that. So say, for example, they did have something that needed to be addressed, a code 1 on their books of hierarchy of challenging circuits. They would call us in, and sometimes just for backup. Sometimes we just sit there and if something goes wrong, we fire back up, we'll get everything working. The other thing that we noticed from a business challenge is the requirement, as they were doing the continuity service, they were doing less capital projects. And we all need our utilities to be healthy. Everybody does. And the way that they make money is a return on their capital employed, or it's in return of equity format. And so getting that capital employed and getting those jobs completed is absolutely necessary for them. And so right now, as they lost the first 9 months of the year to COVID to get that capital work completed, there's a real push at the end of the year now to get that work done in the last quarter. And as David, as you know, there's shoulder seasons within transmission and distribution companies. And they basically lost their first shoulder season to do all that work. And now a lot of work's being pushed into Q4 and get that work done.
Yeah, I can understand how that really does. It's the ripple effect downstream. So it sounds, again, I'm just picking up what you guys are talking about. And I've heard, in our past discussions, Aggreko is there for emergency situations. Power's out, you have a disaster, you can step in with a supply. Number 2, you can step in there with proactive planning work. So you know that you've got a sensitive situation, you can come in and do that kind of like around the heart solution until the fix is done. And then I also love the fact that the insurance opportunity. It's just, you're there just in case. So those are some great thoughts. That, gentlemen, comes to the conclusion of our questions for today at this point. And certainly like to thank you once again for helping outline the technology and solutions that Aggreko provides. Oh, there was, pardon me, I missed one other one. Is Aggreko capable of serving all parts of Canada, portions of Canada? Where can Aggreko serve?
Yeah, so currently we serve all across, well, the world, to be honest, right? So unfortunately, I don't get to go to the hot spots, right? But yes, so I have not yet got asked to go to Hawaii, but if my boss is listening, I'm willing to go. But yes, absolutely, we serve everywhere. We actually do serve in Hawaii. We serve in every continent. We do projects in sub-Saharan Africa. I think we mentioned on the last one, in some cases, they use us strictly as the utility because they're just trying to get electrification at all. We're so very lucky in Canada where we have such a good grid and such a good company. I mean, 84% or something like that, David, you might know the number, is actually non-carbon emitting.
Right, yeah.
Other countries are just struggling to pump sewage away from their drinking water. Yeah. We're so lucky. So we do that in parts of the world. We do these projects. Actually, my territory is all of North America. In fact, I've been heavily utilized in the last couple months over Hurricane Laura and Hurricane Delta now, in supporting the good folks in Louisiana, Texas, and Alabama, and supporting them. And yeah, like my buddy here on the left-hand corner. And so we do work all across there, South America, every continent across the world.
Great, thanks. So basically, if from Newfoundland through to BC up into the northern parts of Canada, should a requirement be made, there's a chance that you could help them.
Even the
we're
Yukon.
We're doing a project right now in as far north in BC as you can go without it not being British Columbia anymore.
Wow.
Yeah.
That's remarkable. Well, thank you again. We're approaching the top of the hour, so thanks again for your time this afternoon. Always learn something when talking to our friends at Aggreko. So with that, Outage, Aaron, and David, thank you for your time. We'll let you go off screen now, and we'll just conclude with the next steps at this point.
Thank you.
Thank you. So for our listeners, our next corporate partner conversation series webinars will be held on October the 22nd. Infosys in Southern California Edison. So listen to this. So Infosys is going to bring on Southern California Edison. They only have about 5 million customers. And they'll be presenting technology solutions in the grid modernization journey for electric utilities. So October 22nd, you want to pay attention to that. And then October the 27th, Infosys will be back again with Arizona Public Service. Now, Arizona APS has about 1 million customers. And they'll be presenting accelerating customer engagement through digital transformation. So if you're interested in these events or other CEA events, they can be found in our monthly newsletter, Current Affairs, which has a subscription of about 6,000 people. You can sign up for Current Affairs by going to our website, electricity.ca, just put it in your email address, and you can get on that distribution as well. Or you can go to the news and events section of our website, electricity.ca. And with that, we're going to thank you for joining us for today. And until next time, bye for now.